All right, guys, welcome back. This is going to be the 9.2 video. And if you remember what we covered in 9.1, we hit two things. Number one, we introduced the difference between a monomial, a binomial, a trinomial, and a polynomial. And these type of algebraic expressions and what makes each which. And it was based on the number of terms present. Then we spent the bulk of our time simplifying polynomials. Specifically, we simplified those that were added and subtracted. Okay, we had a binomial minus a binomial, or we had a trinomial plus a trinomial. And we looked at how to do that, and the key there was if there was anything outside the parentheses, make sure you distribute it through before we end up combining our like terms. Remember, like terms in a polynomial is not only a like base, but also a like exponent. We're going to continue with that today, with simplifying, but we're going to get to a little more complicated examples. But first things first, what I want you to start with is pausing the video and solving or simplifying the following. 5 times x plus 7. How do you simplify this? So go ahead and pause the video, see if you can go ahead and solve it. Well, we dealt with this way back when we were solving equations. We've done a ton of this. You know that when you see a number outside of parentheses, you need to distribute, it's going to be one of our keywords today, distribute the 5 through the parentheses. I need to do 5 times x and 5 times 7 to get 5x plus 35. We actually did something very similar to this in our last lesson when we had a negative out front. The negative acts like a -1. So when we distributed it through, it ends up flipping the sign of everything inside the parentheses. This theme is going to be consistent with our first step in simplifying. Here is where we are going. We're going to start by simplifying the following monomial times the following trinomial or polynomial. Again, those big words I'm using from the last lesson. How do I know this is a monomial and this is a trinomial? I simply look at the number of terms. We discover the number of terms by, if we want to use a shortcut, looking at the number of minus and plus signs present. So anyway, I want to simplify this monomial times a trinomial, and you might not know what you're doing here, but really it comes down to two ideas. The one we just executed, which is distributing, and this is where we're going to really get into applying our exponent rules. We learned all those exponent rules at the beginning of chapter 8. Here comes the application. So you're going to solve this just like you would the ones in the past. And it's going to come from, or not solve, simplify, excuse me. We're not solving anything. And it comes from distributing what is outside of the parentheses. Okay? Just like we would with a standard number, take what's outside the parentheses and distribute it to what's inside the parentheses, making sure you distribute it to everything. So the first thing I'm doing is -4y squared times 5y squared. Well, this is almost a problem within a problem. I did these types of problems, you did these types of problems back in chapter 8 when we were multiplying exponents. So how does this work? Well, when we do -4y squared times 5y squared, remember all of these are multiplied together. So if we can apply our exponent rule. Okay, what am I talking about? Well, the -4 times the 5 will be -20. Again, the reason I can multiply those together goes back to the commutative property, right? The fact that because all of these items are multiplied together, I could rotate around where they are in the multiplication and multiply together certain parts. That's commutative property. 3 times 4 is the same thing as 4 times 3. So I multiply my -4 and my 5 together and I get -20, and that leaves me with multiplying together y squared and y squared. Well, like bases multiplied together means you add the exponents. And I get negative 20y to the fourth. Folks, if this is something that you struggle with or are confused on and you struggle with on your Chapter 8 test, it's okay, but you're behind. Put a little star there. Let me know that you need help. Come see me after school. Attend the Wednesday Zoom session. You have to have exponent rules mastered if you're going to be able to do this type of distribution. So when we multiply together negative 4y squared times 5y squared, we're going to end up with negative 20y to the fourth. And we're going to do this for the next two terms as well. Negative 4y squared times negative 3y squared. Well, negative 4 times negative 3 is positive 12. And again, y squared times y squared would be y to the fourth. When I do negative 4y squared times 2, I'm going to get negative 8, because that's negative 4 times 2. And then there is nothing for the y squared to combine with. There's no like base. So it, just like we saw in Chapter 8, it'll just tag along. And we're left with negative 20y to the fourth plus 12y to the fourth minus 8y squared. Now you might have noticed that we had some like terms within the parentheses. And you might have been sitting there going, wait, Mr. Carter, from the last lesson, I know I could have combined those to make 2y squared. They have like bases, like exponents, therefore they're like terms, so we can do or subtract the coefficients. And you'd be right. But I chose to go ahead and do the distribution first. The cool thing about this is you'll get the same answer either way. Okay? So if you went ahead and combined 5y squared and minus 3y squared first, you'll still get the right answer after you distribute. Since I didn't combine them first, I'm going to combine them down here. Again, we have like bases, y to the fourth and y to the fourth. And so I can combine their the coefficients, excuse me. Negative 20 plus 12 gives me negative 8 y to the fourth. Again, when we're adding and subtracting like terms, notice we don't change the exponent, just the coefficient. The exponent changes when we multiply. And so what I'm left with is negative y to the fourth minus 8y squared. And this is how we do distribution with binomials, monomials, and trinomials. Okay? Same process as before, you're just going to have some exponent rules mixed into the distribution process. So now that you've seen an example, go ahead and try the following on your own. Once I write it out, pause the video and give this one a shot. Okay, so hopefully you've paused it, you've tried it. Now you're here to check your work with mine. Again, when I have a monomial here, but when I have something outside the parentheses, I'm going to distribute it into the parentheses by multiplying it by everything in the parentheses. When I do this, I have negative 7h times 3h squared, which gives me negative 21h cubed. Again, like bases multiplied together means I add the exponents. Negative 7h times negative 8h will give me positive 56h squared. Again, when you don't see the exponent by the h's, that means they have an exponent of 1. So when I do negative 7h times negative 8h, I have two h's, h squared. Negative 7h times negative 1 gives me positive 7h. Positive 7h. And this will be my answer. Negative 21h cubed plus 56h squared plus 7h. And that's how we simplify polynomials, monomials, binomials, trinomials when they are multiplied together. Same distribution process we've been doing in the past. It just gets a little more complicated and we have to utilize our exponent rules. Again, I can't stress this enough. If you struggle with exponent rules, please pause the video make a little star and let me know so I can help you. So we handled our simplification, but now we're going to enter something called factoring. And factoring, I would want you to write the definition down. Factoring is the opposite of distributing. Whereas distributing, we take something outside the parentheses and distribute it to whatever's inside the parentheses. Factoring is identifying what each term has in common and taking it out. We distribute something outside the parentheses via multiplication. So you can imagine when we identify a greatest common factor, a term you should know, among different terms, when we take that out, we take it out by division. So then we're going to start this process by finding the greatest common factor in each term. And let's start with maybe an example you've seen before. 2 plus 8. Now don't combine it and make it 10. But what I want you to do is I want you to look at these two numbers and identify the greatest common factor present. Well, when I do that, the greatest common factor would be 2. So to factor out a 2 from each term, unlike distributing where I multiply to distribute something, to factor something out, I'm going to divide each by its greatest common factor. I will then pull that greatest common factor out front. Well, 2 divided by 2 is just 1. 8 divided by 2 is 4. And thus, I can rewrite 2 plus 8 as 2 times 1 plus 4. Check your work. How do you know that they're the same? Well, 2 plus 8 is 10. I know 2 times 1 plus 4. We can simplify what's in the parentheses to be 5. And 2 times 5 is also 10. Either way, you get the same answer. But the process I've done here by identifying the greatest common factor among each term and taking it out front via division is called factoring. So now let's try it with some polynomials. 4x cubed plus 12x squared minus 8x. So the first thing I want to do here, before we really get into the factoring side of things, let's just identify the greatest common factor in each term. Now, this might be difficult, and you might have never done this with variables. So go ahead, pause the video, and see if you can do it with numbers. See if you can identify the greatest common factor present with the numbers. Well, once you do that, what you probably came up with was 4. 4 goes into 4. In other words, 4 is divisible by 4. 12 is divisible by 4, so 4 goes into it. And negative 8 is also divisible by 4. So the greatest common factor would be 4. But how do we do this with variables? Well, it's kind of going to go back to what I said at the very beginning of exponent rules. When in doubt, write it out. If you struggle to identify greatest common factors among exponents, go ahead and write out what the exponent means, and it'll become very present. So if I go ahead and write out what's in black, I have 4 times x times x times x plus 12 times x minus 8 times x. And so what we can do here is when we write out our exponent, what you can see here, it becomes very easy to identify what the greatest common factor is. I have 3 x's present here. I only have 2 here, and I have 1 here. What's the greatest common factor in the variable in terms of the x's? 1x. So what am I going to do? Well, I'm going to factor out an x from each. In other words, factoring that out means I'm going to divide each by an x. But we'll get to that in a minute. Right now, we're just identifying the greatest common factor. The greatest common factor present of 4x cubed plus 12x squared minus 8x would be 4x. Okay? It is the greatest thing that all 3 terms have in common. Okay? If you look at this and you don't feel like you need to write all of this out, that's okay. If you want to jump straight from the first step to the third or your answer of the greatest common factor, that's fine. But again, if writing it out helps you identify what the greatest common factor is, go for it. Okay, let's try another example. 4x cubed minus 2x squared minus 6x. Pause the video. See if you can go ahead and identify the greatest common factor in this polynomial. Okay, you've paused the video, you've given it a shot. So what is the greatest common factor in this polynomial? Well, the number part's pretty easy. I look at all three of those coefficients and I notice they have a 2 in common. So I will factor out a 2. Now do the same thing for the x variables. I have 3 x's multiplied together in 4x cubed. I have 2 x's multiplied together in negative 2x squared. And I have 1 x in negative 6x. The greatest common factor, therefore, would be 2x. Again, if you want to see that visually, go ahead and write out your exponents. When I do that, I can easily see that the greatest common factor that they have in terms of looking at just the variables would be a single x. And we see that in the negative 6x. So my greatest common factor for the whole polynomial would be a 2x. If you feel like you're struggling with this at this point, again, pause the video and start it. Because now what we're going to move on to is not just identifying the greatest common factor, but also how do we actually factor it out. So again, pause the video, shoot me any questions via email that you have to this point. So once we identify the greatest common factor, we are going to divide each term by it and write the greatest common factor out front. This is how we finish executing the process known as factoring. Again, why are we dividing? Well, it's the opposite of distributing. When you have something outside of the parentheses and you want to distribute it into the parentheses, you multiply each term by it. Factoring, we're identifying a greatest common factor, and we want to take it out front. We need to divide. So let's look at an example. Let's say I have 3x cubed minus 12x squared plus 15x. Well, first things first, if I want to factor this, I want to write it in its simplest form by factoring it. I need to identify what each term has in common, aka the greatest common factor. When I look at this, I notice that the greatest common factor of the coefficients would be a 3, and of the variables, it will be an x. Again, if you are unsure of this, go ahead and write this out, and you will quickly see the greatest common factor is 3x. Again, if you're struggling with that, let me know. So if my greatest common factor is 3x, how do I finish the factoring process? Well, what I'm going to do is I'm going to write a 3x out front, and then I need to divide each term by 3x. Let me write this a little lower. Divide each term by 3x. Again, this is going to go directly back to our exponent rules. What I have here in each case is a like bases divided by each other. So what's our exponent rule say? Subtract the exponents. 3 divided by 3 is 1. X cubed divided by x. Like bases divided by each other, subtract the exponents. 3 minus 1 is 2. So I have x squared. Negative 12 divided by 3 is 4. X squared divided by x is just going to be x. Again, 2 minus 1 is just 1. 15x divided by 3x, the coefficient will be 5. And again, x to the first power divided by x to the first power, subtract the exponents, I get 1 minus 1, which is 0. X to the 0 power is just 1. 1 times 5 would just be 5. And if you want to see that little logic written out, x divided by x would be x to the first. So I do 1 minus 1, and I get 0. So I would have x to the 0 here. But we know that x to the 0 is just 1. We know anything times 1 is itself. And so, factoring this polynomial, I have identified my greatest common factor of 3x. I have taken the 3x out front and then divided each term by the 3x to simplify my polynomial. This is the process of factoring. Let's try a couple more examples. 8x squared minus 12x. Go ahead and try this on your own. Identify the greatest common factor, take it out front, and divide each term by your greatest common factor. So pause the video and give it a shot. Well, to solve this, let's identify our greatest common factor. When I look at 8 and 12, I notice that the greatest common factor they have among the coefficients is a 4. And among the x's, the highest power I have is x. If you want a shortcut for identifying the greatest common factor when you're looking at the variables, make sure every term has the same variable present, and then identify what the lowest power is, and that'll end up being your greatest common factor. So my greatest common factor is 4x. Again, you could see that by writing it out if you would like to. So now I'm going to take the 4x out front, and I need to divide each term by 4x. Well, 8 divided by 4 is 2. X squared divided by x, like bases divided, subtract the exponents, and I get 2x. Because 2 minus 1 is just 1. Negative 12 divided by 4 is 3. X divided by x, you would subtract the exponents. 1 minus 1 is 0. X to the 0 is 1. A shortcut you can recognize there. Anytime you have a fraction with the same thing divided on the top and the bottom, it will cancel out. And so we're just left with 2x minus 3. So this would be the factoring for the polynomial, or the polynomial, but also the binomial, x squared minus 12x, 4x times 2x minus 3. Okay, folks, this will be our last example that we do next. Again, please really give this one your all. Try it on your own. And this is going to be a great marker if you understand factoring or not. You've seen some examples. You know the process at this point. So this is your test problem. Can you do this? If you factor this correctly on your own while pausing the video, I would say you probably have factoring mastered, at least the intro to factoring mastered. Okay, so test yourself. Okay, you've tested yourself. Let's solve it. Our greatest common factor, well, each term, each coefficient has a 6. And if we look at the variables, the highest, or every term has an m in common, but that's the most. I could not say m squared, for example, is the greatest common factor because we don't have an m squared with the negative 24m. So since all terms have an m, we can factor out a 6m. So now that I've identified I'm going to factor out the 6m, I need to divide each term by 6m. Well, 6m cubed divided by 6m will leave us with m squared. Again, this is because 6 divided by 6 is 1. M cubed divided by m, like bases divided, subtract the exponents, and I get m squared. Negative 12m squared divided by 6m gives me negative 2m. Finally, negative 24m divided by 6m gives me negative 4. And so my factored form of this polynomial 6m times m squared minus 2m minus 4. Guys, this is our video. Again, we covered two big concepts today. One, how do we distribute monomials or how do we distribute monomials into polynomials? Again, how do we do multiplication with monomials and polynomials? And then we learn the opposite. Instead of distributing, what is factoring? And what does factoring look like? And how do we identify the greatest common factor and take it out of a polynomial? Again, if you have questions at any point, let me know. Otherwise, have a great day.